My name is Jose Palafox, and I used to live in Portland. I'm really excited to be back here for this event, so thanks so much for having me. I moved to Portland in 2007 when I got a really generous package from Reed College, so finished up at Reed and helped start a software company here called Puppet Labs. If anyone's familiar with Puppet, we did really well for a couple years, and then didn't end out so great. But it was a really fun ride, and Portland was my first real home, where I felt really comfortable. So I'm just super happy to be back here. So thanks so much for having me. I work at GitHub, and my job is loosely to work with all of the largest software companies in the world and talk to them about open source security, help them adopt better security practices, and help them build more secure applications that we all use. So what I'm going to talk with you about today is really kind of the state of GitHub and maybe why you should care about it as a security professional. And I'll take you through some of the things that we've been doing at GitHub over the last 5 years or so to really improve the quality of security of open source packages on GitHub. We've introduced a ton of tools and to share kind of what those things do, how you can use them for free on GitHub if you interact with GitHub. And then I've kind of got a persona-based approach to give you some actionable things that you can take away today, kind of no matter who you are in the room. There's stuff that you can do to help us secure the open source software on GitHub. So that's sort of the structure of what we'll do today. So what is GitHub? Who has a GitHub account? Everybody. All right, fantastic. Tech room, we nailed it. Got it. All right, so you are one of the 100 million plus developers that are on the platform, but it's also the home to most open source software, and that's probably how people first familiar with GitHub. I talk to students all the time, and they'll say, GitHub, that's the thing that I download R scripts from, and I really like that. And they're like, oh yeah, help you pass your stats class. So it's great. It's a place where people come and they share code. And why you care, I think, about it is because open source really changed the way that enterprise applications are built, and anything that we interact with today, whether it's the wristwatch that we have, or the phone, or the car we're driving in, or the elevator we're riding in, most of the software that runs all of those things is based on open source software, which hopefully is a truism at this point. This used to say open source is changing, but I've changed it to past tense because it just seemed too obvious that we use a ton of open source now, and all of that lives on GitHub. A couple years ago, we started having this problem on GitHub, and it alerted us to this responsibility that we have to help secure open source software. People were leaking their API credentials all over the platform, and this happens 300 times a day. People will push a live GitHub token to github.com. A malicious actor will scoop that up from our events API, and then they'll take over that account. So not only were we dealing with a lot of account takeovers, it was starting to put some of the open source software on GitHub at risk, because if a maintainer lost their own identity on GitHub, somebody else could create a supply chain attack out of that identity of the maintainer that owns like a popular package. So impersonating somebody on GitHub is a really bad thing, and this was happening 300 times a day. So we had a serious problem. So we built some tooling I'll talk about to address this, but this was like the first big whoa, we got to do something. This is more of a longitudinal thing that we looked at over time, but what we saw over the years and from running static analysis tools on GitHub, the number of security vulnerabilities that we found on the platform basically stayed consistent with the number of lines of code that were being written. So even though people were becoming more aware of security vulnerabilities and better application coding practices, we were still introducing loads and loads of vulnerabilities, and that's what you see with this blue and red line basically staying in the same curve here. This is a complicated double y-axis, and one of the lines doesn't have an axis, so bear with me. I promise it's not false news. The purple line there is really people becoming more aware of it. You see this sharp spike in 2018, 2017 timeframe where people started commenting a lot about how their PRs were resolving security vulnerabilities, but still the number of vulnerabilities stayed about the same ratio with lines of code written. So the situation wasn't getting better. So we said, okay, we have this secrets problem. We have a problem with introducing code vulnerabilities, and this is happening all over the platform. And when you look at analyst data, they'll tell you kind of the same story in these big numbers. And what jumped to me about this data is really this last bullet. 81% of devs still choose to ship vulnerable code to meet deadlines. And as security people, I hear all the time talking with you that you just feel like your devs aren't listening or they just don't care. Does anybody feel like that? No? Sometimes? A few? Okay, no one wants to admit it. It's all right. I've heard people, you get a few beers into people and they'll really let it go. But it's okay. Sometimes your devs aren't listening to you, right? And it's not that they're not listening to the advice that you're giving them, but they're inundated with so many things. I mean, a lot of stuff falls on a developer's plate all day. And as working at GitHub, we're advocates for developers. We really try to understand what's going on in the developers' day-to-day and how to help them. And we went out and talked to developers about why they're ignoring security vulnerabilities, like what's going on that's causing them to just sort of like bypass any noisy alert you stick in their face. And they told us two really big things. One is that there's too many false positives. This industry went through this huge groundswell of VC investment, and now there is an alert for every single thing that could possibly happen in code. And developers are inundated with thousands of these. If you work at a knock, maybe you're like, that's my job. I see lots of colors, and I like responding to that. But developers don't, and they train themselves to be efficient, and they see too much noise. Something they go and investigate, and it turns out to not be a problem to them, and then they just stop paying attention to it after that. The second thing they told us is that context switching is more expensive than people realize, and I think as technologists we understand this, but the frustration that developers go through when they're trying to remediate security vulnerabilities is sometimes really arduous. Like they don't have the right permissions to view the dashboard to understand what the alert is, so they could spend a week trying to understand if a vulnerability that's being reported to them through maybe some internal tool that pings them on Slack is really something that they have to care about. And by the time they get to it, it turns out to be a false positive or something that they don't care about, and that whole cycle just discourages them from ever paying any attention to security alerts. So we've got to fix that, right? There's a user experience problem that's going on here. So we took kind of a multi-pronged approach here. There's an aspect of this where we need to introduce tooling, and so we'll talk about some of the tools that we introduced. We also had to go and educate people, and so part of me being here today and my wonderful marketing team giving me funds to come out here, is helping do some of that. So I'll help kind of share the goodness that we're working on so that you're aware of it. And three, we're building a security community. So I'll share some of the resources around how you can join that security community and what assets are available to you there. There's some really nifty stuff we have on the platform. I want to spend a little bit of time talking about three of the features that were on that page. And this is all free stuff on github.com. So if you're an open source maintainer or you use GitHub, this isn't like a sales pitch for you. This is tools that are freely available. They're just buried in settings pages. And so I want to come and kind of share where to find some of this. But the three big investments we've made are in static analysis. The first static analysis investment we've made is code scanning. So this is an acquisition we made of a tool called SEML. SEML is a static analysis security testing tool. It identifies insecure coding patterns in applications, and it's built directly into GitHub. So on every pull request, we can run a static analysis check to say, hey, does this new code contribution introduce any vulnerabilities? And if it does, then we can take some action on it. The second piece of our static analysis story, and static analysis obviously because we're the SCM, we have all the code sitting there at rest so we can look at it. So the second piece is secret scanning, and this was going to that first problem we talked about of having 300 plus tokens being leaked on the platform a day. We teamed up with AWS in sort of just a very informal way to say, hey, we're sure you're having this problem too. How do we try to solve this? Let's run a regular expression tool, like let's identify patterns in code as they're coming into GitHub, and if we find them, if we find API keys that match our regex pattern for them, we'll tell you about it, right? And we'll start notifying the users that, hey, their key may be compromised. And it's not just in the push that you're making to GitHub. A lot of times this happens in the Git commit history. So users are just unaware that the Git commit history comes with the commit. And so they'll think, oh, I tested this local database connection and everything worked great, and then I deleted the key and then I published it. And now you have a secret online. So we worked with AWS to solve that. So I'll talk about both of those. Either I'll say CodeQL for code scanning or secret scanning, but these are kind of the big bucket features. The last piece that I'll talk about a lot is this product called Dependabot. Again, also free. Dependabot is a tool that looks at all of the dependencies that are in an application, and it compares the versions of those dependencies and transitive dependencies with known vulnerabilities for those packages. And if we find that you're using a package that has a known vulnerability in it, then we'll go ahead and alert you that, hey, you should upgrade this version, or there's a patch version over here, or this has a CVE that you should pay attention to. So this kind of comprises the big rocks in the story. The rest of the stuff on that slide was more configuration settings, so we'll talk about both of them, but just kind of wanted to lay a baseline down of what the tools are and what we're talking about here. As important as the tools are, the way that the tools are built is also really important. And so I mentioned we talked to developers, and we talked to a lot of developers about this security problem to kind of understand what we needed to do. And so our approach to introducing all of these static analysis tools was really this kind of three pillars here. One is developers want collaboration. They need ways of asking questions without having to change screens and going to other places. And so using some of the, the collaboration features built into GitHub, now if you turn on the security features, it's very easy to escalate a pull request that's being blocked by a static analysis tool to a security team to say, hey, I don't understand what this alert is. Do I need to pay attention? Can you help me with this? Can you help me remediate it, right? So give them ways of working in the community and contacting senior devs or security leads on projects. The second big piece is they want it all in the platform, right? They don't want to go somewhere else. So whether they're working in the web UI or the IDE, as much as possible, they want alerts delivered to them locally without having to navigate away to some other location. And last, they don't want to think about it. They just kind of want it to be automated. It should just be a thing in the background that developers don't have to care about. And so that was sort of our approach when we built all of these tools. And I've had this graph. This is one of our oldest views or oldest slides I've had when having these talks with customers. But it tells the story just so clearly. When you automate and inject a security process into the developer's workflow, they respond to it. And that's roughly what this graph is saying. When you turn on Dependabot and it automatically raises a pull request for you to update a version, it's really easy for you to go, yeah, I do want to update that version. I don't want to be exposed to that vulnerability anymore. That's simple for people, and they get it and they respond to it. And you just see that engagement happen as soon as we start putting these tools in front of the developers in this way. Oops. The second thing, not the second thing, sorry, we see this with all of our tools. So I talked about those three big tools, and they've all basically experienced the same response rate from developers. When we went back and looked at static analysis scans of code, we saw that alerts were getting remediated, maybe 15% of the time within the pull request, right? So if a tool blocked you or told you like, hey, this lint is off, you should fix it, 80+% of the time, developers were just ignoring it. When we started adding PR blocking scans in, developers respond to that, right? They will remediate them 70+% of the time, in 7 days, which is really wild, right? As security people, this lowers the amount of alerts that we have to look at that a developer is claiming are false positives or that are being pushed into code and bypassing our security processes for us to go back and remediate later. We've also blocked a ton of these secrets, and I'll talk about how we've done this in a little bit, but we've gotten the scans for API credentials down, in many cases, to less than 1% false positive rates. And so we've started blocking commits before they're written into the project so that keys don't get distributed to other copies of the project when it's downloaded. And so we've blocked roughly 20,000 of them, which is really exciting. So all of these tools are implemented in the same kind of way, where we create automated pull requests wherever we can. We sort of run automated in PR and provide as much context to developers natively in the platform. And when we do that, we get really good results out of it. We started taking these tools that we were building and applying them to the open source software, and I think this is probably the first of what will be many QR codes. So if you feel like taking pictures of the slides or you want relevant blog posts that I'll link you to here, feel free to pull those out and zap a picture or follow the QR code, but there'll be links to everything. This one here goes to the Security Lab landing page that you can take a look at. But we through these acquisitions, we hired all of these security professionals, and so we put them in an organization called the Security Lab. And what they do is they use our static analysis tools to go out and look at open source projects and evaluate whether or not we find novel vulnerabilities in them. We do this 200 plus times a year, but what's really exciting is that when you add the tools aspect that we talked about, plus a little bit of helping hand from somebody that understands what's going on, we can get that remediation rate up to 95%. So 95% of the PRs that we make on projects to alert them about an open source vulnerability get fixed, which is really, really exciting. So this has allowed us to build the largest or maybe second largest database of open source vulnerabilities in the world. So all of the vulnerabilities that we find, we make freely available on github.com/advisories. And this is just like NVD or other vulnerability databases. You can pull it down freely. It's also what our Dependabot tool uses to check whether or not any dependencies in your project have a vulnerability associated with it. But that's been built up and curated through all of these research efforts put on by the security lab. Okay, I know I've been talking a lot. Give me a second here. I'll get some water. Any questions?
With your advisory database that you have in there, does it also quantify out severity level? Like this was down to a low, this was down to a very high.
Yeah, we report the CVSS number associated with it, so that will come out. Where we're headed with this longer term is trying to tell you whether or not that vulnerability is reachable. We can talk maybe more about that offline, but that's sort of where the industry's going, is like, hey, it's not only that I want to know that it's a critical, but I want to know if it's a critical to me. And so we're working to solve that problem. I can give you a little update there. Okay, so that was a lot about the GitHub, why you should care, and what we're doing to try to better secure the open source software that all of our daily lives depend on. But there's a lot that you can do as individuals to kind of help us on this journey. And so the rest of this presentation is really kind of a persona-based approach to how do I use some of these tools to improve security on GitHub or even in your own company. And the first thing I've got for you is please turn on two-factor authentication. This is the single best thing that we can do to prevent people from taking over our accounts and to stop supply chain attacks. Who has 2FA enabled on their GitHub account? Okay, security room, all hands. Let me tell you, look, if you lump GitHub in with like social platforms, right? And you think about social platforms broadly, and this is some Twitter math that I did a while ago, but what I hear tell is that most social platforms have an adoption of around 2% 2FA. Right? That's really spooky. And this is, we're a bit better. We're maybe 5, 7, 8x that, right? I don't know where we are now, so don't take that as a hard number, but we're drastically improving. And we want to do even better. So by the end of this year, anybody that contributes to github.com will have to turn on two-factor authentication. It's no longer going to be an option. We're just going to force people onto this path. So that's a really exciting milestone that we're moving to. This has taken 3 years for us. We've identified cohorts of top maintainers and open source groups that we needed to migrate onto 2FA. I ran a program with a handful of other people in the OpenSSF, which is the open source software security foundation. More S's than I care to remember. To give out 2FA tokens. So I went around emailing, hey, Twitter Bootstrap, would you like MFA credit tokens? And we mailed them YubiKeys to turn on 2FA on the platform. So this is something we're taking really, really, really seriously. So seriously that we created the GitHub mobile app, in a large part to be a one-time based, password tool. So if you don't have a TOTP provider, you can use GitHub Mobile as one. I downloaded it for that purpose because they made us as a part of working there, but I actually really like the app, so I think small plug, GitHub Mobile is very cool. You're not going to code on your phone, but you can review a PR, you can +1 things, and it makes using comments way easier. It's really, really good. The coolest thing we've done here is gone passwordless. So now if you want to use the bio key on your laptop, or you have a YubiKey bio or some other two-factor authentication device with fingerprint or face scanner or something like that, you can also use that to protect your account. And I think over time what you'll see is more just-in-time two-factor tests during deployments or changes on GitHub. So you'll see us get more assertive with how we're requiring 2FA on the platform over the next couple of months. But our first really big milestone here is just requiring on the platform in order to contribute to it. Another thing that you can do as an individual on GitHub is you can enable a feature called push protection. And what this does is it opts you into a security feature that will scan any commit that you're making anywhere on github.com. And if we find an API credential, we will fail your commit. So it won't hit the project. It'll come to GitHub, we'll evaluate it, and we'll say, nope, it looks like your Amazon token's in here. We're not gonna let this go through, and we'll just block you from making the commit. You'll get a little output in your IDE or in the UI that says, hey, on line 43, it looks like you left your token. Go back and fix that, and then re-push it. There is a way to bypass this as a gentle block. You can say, nope, I'm definitely sure I'd like to get owned. Let's do this, and you can do it. But this is a really great, just passive check on yourself. Like I said, and I'll show you how we did this in a few minutes, but this is not noisy. And I worked on this program to collect all the regex patterns for all of these API tokens. We've got a less than 1% false positive rate here. You're not gonna get a bunch of noise out of this tool. We're really cautious about not wanting to block developers from being productive on the platform while still being secure. So this is a really, really cool feature that you can turn on for yourself. Again, all this stuff is free. Okay, let's say you're gonna go another layer deeper on GitHub and you actually make a project. You have a JavaScript library that you distribute or some open source community that you're active in. You can do things as a maintainer that are even more important than what you can do, well, not more important, but are as important as what you can do as an individual. The big one being enabling these code security and analysis tools. And this is in a UI page, you go to setting, code security and analysis. I say code security analysis all the time. It's my favorite page on GitHub. This has all the settings for turning on code scanning, secret scanning, and Dependabot for you. There's a number of other features on there. I sort of cropped this image so it told my story better, but it's a nice UI page that you can go down and enable all the security features for your open source project. This will give you the same kind of enterprise grade tools that we use with our customers completely for free. So please go use these. They're awesome. This will opt you into Dependabot, to code scanning, into secret scanning. Another big thing that you can do as a maintainer is to turn on private vulnerability disclosure reporting. And this is another setting on that code security and analysis page at the repo level as a maintainer. And what this does is it creates a security policy for your open source project for you. If someone wants to alert you about a security vulnerability that might be present in your project, they can responsibly disclose that to you through GitHub. There's also kind of a UI experience to create a branch and work on a patch privately with the person disclosing the vulnerability to you. So, instead of having people reach out to you over Twitter or trying to email you to an email that they're not really certain is going to you, or going through a contact us form and saying, hey, I think I found a security vulnerability on this tool, there's a way for you to alert open source projects or to get alerted directly in GitHub now. So really cool feature, but you have to turn it on your project. So this is another one that you can go ahead and enable. And this is how we contact many of the open source projects that are on GitHub today. When we contact you or you get contacted by somebody, if you agree that it's a vulnerability, you can submit it, and we're a CVE enumerator. So we'll actually issue you a CVE for that vulnerability, which is really cool. And that's made GitHub the #1 issuer of CVEs for open source software in the world, behind MITRE, I think, who the government pays to put on the whole program. But really exciting stuff. It's turned into a really fantastic feature. So if you work on any open source projects, it's an easy one to flip on. Okay, let's say you work at a service provider. You make a product that touches developers in some way, or maybe at work you just have services that developers use that are internally developed. The big thing that we can do with you here is add you into this secret scanning program. This is a free program, so anybody that makes any kind of developer tool that spits out an API key, we can add into this program, and you can you follow the instructions on the QR code if you want to reach out to us to join this program. I've personally added tons of companies into this. It's really exciting. But what we'll do together is we'll work on a regular expression for your API credential. And then if we see that API credential on GitHub, we'll send you a payload that says, hey, at this URL, we think that you have a user's credential exposed on the internet. Please contact them and help them remediate it. If you get an email from a service that you're using telling you that they think that they found an API credential associated with your account on GitHub, this is very likely the service that's getting used to notify them. We'll send them a payload and say, hey, here's where we think the match is. Go look it up and contact your user. So anybody can join this program. It's really, really cool. What does this look like in practice? This is just a fun demo that hopefully I'll get some laughs out of, but if not, no pressure to laugh, but hopefully it's funny. I tried to prepare a demo for this for a different, a different talk, and I leaked an AWS key intentionally into my public repository on GitHub. So this is what that whole process looks like. AWS sent me an email basically saying, hey, we found this key in this URL. Has anybody gotten this email before? Someone's lying. No, I'm just kidding. All right, so then I got this email. This is really cool. This is telling me that I'm turning up compute in Japan, and I'm not. And that happened 20 more times in a couple of minutes. So if you would like a really quick way to burn down $100, leak an AWS credential on GitHub, and 4 minutes later, you'll have spent your $100. You'll spend the next 4 hours deleting all of these instances and regions and then working with AWS to remediate it. And when you get through that, they'll tell you that you're good to go. But that's what it looks like if you push a key online, and it happens tremendously fast. When I did this demo and when we were introducing this feature, the big thing was people grabbing compute credentials so that they could mine Bitcoin with them, right? So they get into your Amazon environment, and then they turn up the biggest instances in the most expensive regions and just party doing math problems. But we added this thing, push protection. And I talked to you about this as individuals. So now if you leak one of these patterns, this is what will happen in your UI or in the IDE. You'll get a notification basically saying, hey, it looks like you're about to make a major whoopsie. Please stop and don't do that. So this is push protection. It's very cool. But this is powered by regular expressions. And regular expressions are really messy. Anybody who's worked with them will tell you a really funny regular expression joke, I'm sure. But yeah, they're not fun. So we have a couple best practices, and this applies to any internal developer-facing services that you may maintain at work or that your teams are maintaining or using. There's a couple of good rules to follow here. So one is to create a prefix. And what this lets us do is really confidently understand that this is a token. This is where a token begins, right? And if we have a consistent prefix, we can tell what service this token's from. We can tell all kinds of information about it. So a prefix is just very helpful. We also use underscore anytime that we are creating space in the line or in the string. If you use dashes, when you try to highlight it, it will only highlight the segment in between the dashes. If you use underscore, it'll highlight the whole thing, which is a very silly UI thing, but it matters a lot because it prevents people from pasting around the wrong thing. So underscores are also another pro tip here. Obviously, you want a lot of entropy in the string. You can dial that up or down however you feel like. But the last big kicker is adding a checksum into the credential somewhere. And what that really lets us do is dial in that false positive rate. If there's a checksum in the credential, I can validate that it's a real key without having to do a database lookup, which makes it super easy for me to just say, yep, that's a real key, that's not a real key. And if I change 2 or 3 characters in that AWS key I went to leak, it'll just let it go because it knows that it's not a real token. So when I said that the tool is super duper accurate, the checksum is like the magic. That's the magic that happens there. So if you're building any services internally, or you build a service that developers interact with, embed a checksum in your token and let us know about it, and we'll prevent people from pushing it onto .com. Okay, security researcher. This one's going to go a little extra nerdy, so I hope folks are ready for that. This is a niche slice of the world, but it's super interesting to see what's possible here. If you're looking at getting into doing security research, or you want to make money from bug bounties, or you just want to practice identifying the vulnerabilities that you're here learning about today, or through other education, this is a great tool that you can use. It's called multi-repo variant analysis, and it's very poorly named, or very long-winded named product, but very cool and very descriptive. So I'll leave this up for a second, just so you can grab the QR code if you're interested. But this is a really neat way of leveraging that code scanning capability in kind of a unique way to hunt around for bugs. And to understand how you do that, we've got to know a little bit under the hood about how our code scanning tool runs. What it does is it looks at the source, it checks it out, and it builds it. or compiles it. And during that process, we generate a database representation of all of the data flows and control flows in the application. And then we have a query language, CodeQL, as the name implies, that evaluates whether or not there's insecure coding patterns present in the code. All of the queries that we distribute are open source, and again, this tool's all open source. So we do the evaluation, and then we plumb all of the results back into your repository. So if you turn on CodeQL, this will happen using GitHub Actions in the background for you, and you'll start getting results into a security feed. What we also do is we save that database, because why would we throw that away? We just spent all that compute building it, so let's keep it. And over time, what we've done is we've sort of put most of GitHub through this process. And so there's databases present on GitHub for millions and millions and millions of projects. And so if we invert the model, rather than asking, hey, of these open source queries that we know find known security vulnerabilities, what if I write my own query? Because I want to know if this pattern is present somewhere else. I want to look for a variant of a vulnerability. I want to look for something that's similar but not quite the same. I can write a query, and then I can query all of those stored databases on GitHub and get a result. These 10 databases have this type of problem. And you could do that for performance issues. You could do that for any kind of like data question about an application. You could write a query in CodeQL, and then you have millions of databases that you can run this against. So as a security researcher, if you think you find something new, and you want to understand if it's a common problem in other open source packages that maybe your company depends on, or you're just interested in submitting these bug bounties, you can write a query to find it, dial that in a little bit on the project you're working on, and then very quickly you can go and query all of GitHub to see if other projects have the same vulnerability. So this is a really cool way to develop kind of your security research skills, and also just participate in the community. If you find something, tell people about it, right, and definitely check it out. If you're interested in becoming a security researcher or auditing things using CodeQL, you're welcome to join us on Slack. This is all run by the security lab group that I talked about earlier, but they have a whole community of people that participate with us in responsible disclosure and writing queries for new vulnerability types, responding to 0 days together. This is a very active community. If you're interested in writing CodeQL queries, this is a great spot to get involved in. You're also obviously welcome to participate in our bug bounty. We do pay, so if you find something wrong with GitHub, please tell us, and we'll adequately reward you, hopefully. Okay, last little bit here. So what can I do at work? And this isn't a sales pitch, but the headline is like, everything I talked about you can buy for your enterprise if you want it. But there's a few specific things that you can do at work that are totally free, and that I would encourage you to check out. One is to use Dependabot. If you're a GitHub user, this is included in your standard GitHub subscription. So you can turn on Dependabot. It's a no-cost security feature that you can turn on and start evaluating your dependencies. But also the tool itself, Dependabot Core, the thing that evaluates the dependencies of an application and then compares them with our database, is open source. So you can use it with any version control system you want. You can extend that application. You can run it internally. So that's on a very permissive license that you can go grab. So use Dependabot or something like it, but check your dependencies. And more important than checking your dependencies, talk with your developers about why they're taking dependencies on certain libraries. Sometimes it's easy to go really fast and to not think about the quality of the security posture of a transitive dependency that I'm somehow inheriting when I want to add like cool color scheme to my website. And so I would develop a talk track that you have for developers about what you're looking for in a good dependency and educate them about what they should be looking for. And if you're not sure how to have that conversation, or you don't know what's important, I would encourage you to check out this project called the OpenSSF Security Scorecard. And what this is a group of security folks got together and said, hey, here is metadata that we want to know about a project. How many contributors does it have? How many companies are those people from? How frequently are they contributing? Do they run static analysis tools? Do they run an SCA tool? Do they run any, this tool, the next tool, the next tool, right? And we want to know whether or not these open source communities are following security best practices before we take a dependency. And this tool will just quickly evaluate a given repo for all of those points. So we work to help them get the data from our API and to kind of correctly call it and search for it. And they store all of that in a BigQuery database hosted by Google. So if you go to this project link, you can either run the tool on a target repo, or you can just check the database and see score output and also the individual values for any project that a developer wants to take on. So you could imagine having a workflow where a developer tries to modify a package manifest inside the repository. That triggers some workflow where you run the OpenSSF security scorecard on the target that they're trying to bring in, and then if it passes whatever your bar is for including a dependency, you can go ahead and let them continue on and get out of their way, or you can go have a conversation with them about it. But this is a really cool tool for being able to talk with your developers about security vulnerability. Sorry, I see a few phones out, so I'll leave this up for a second. Another thing you can do at work is educate suppliers about this secrets problem. I have spent tons of hours going to contact us forums and trying to, dear company, whatever, you make a SaaS tool that interacts with developers, please make an identifiable token. And nobody, not nobody, but oftentimes no one responds to that. And I have to try really, really hard to get people's attention. And finally, when I get someone's attention, sometimes they'll say, I'm not hearing that from my customers. And so I would really invite you to tell your suppliers during whatever security review you're running them through that you want them to have a downstream identifiable API token. And this isn't just for our service. I'll consume that information if it's given to me, but there's open source tools that do secret scanning as well, and they all run on regex, right? So we're all doing the same kind of approach with regular expressions, and this is still the best practice for figuring out whether or not an API token has been leaked. So if you're doing a security review with a vendor that you're onboarding, tell them this is a requirement, please, that you just want to be able to know if their token has been leaked in code. Easy, right? Easy. I'll really appreciate your help. This is not Dropbox's, this is DigitalOcean's token, and I took their logo off because I never know the approach I'm coming into this slide, so I want to make sure I say it positively. But we worked with DigitalOcean to upgrade their token type, so you can actually see what this before and after for both us and for them look like, right? And these are both products of just using random numbers to generate entropy, right? We just didn't think about downstream token identification as a thing that mattered to us. So when we change these, now we can identify them anytime they're leaked anywhere. So tell your vendors to follow the lead that DigitalOcean set and hopefully GitHub set and do this. I keep repeating myself on that point because it's like, I've worked so long on this. I really appreciate your help. Okay, so last slide. I think I did okay on time here. We're 10 minutes early, nice. So what did we learn about today? We learned about the open source supply chain and how it comprises most of the software that your teams are writing today. And most of that, much of it, comes from GitHub. So this is important. We talked about the developer experience on GitHub and how security tools need to take a developer-first approach in being presented to developers. Otherwise, they just ignore them, right? And this is important if we want results from those tools, right? If we keep buying tools that generate noise and don't produce remediation action, we don't get any further in the problem, and that's been sort of the underlying note through this whole presentation. So when you're evaluating security tools, or when you're thinking about how you want to make security changes to developers, pick and choose how you're going to do that and when you're going to be assertive about it and when you're going to try to fit into their process. Think about it a little bit. With 2FA, we're asserting it, right? We're just tops down saying, if you contribute to GitHub, you got to have 2FA. But in other cases, we're not opting you in to push protection. You have to go and do that. We're not opting you in, to code scanning on your code if you don't want that to be there, because that's just a source of noise that you're not asking for if you don't go turn it on. So, meet your developers sometimes. And the last piece we talked about was sort of this community of researchers that we're building around the tooling on GitHub, and really hope, if nothing else, take this as an invitation to join that community and work with us on making open source software more secure. So that is my presentation for you. Okay, so this QR code goes to a landing page, and if you want, you can dump your email address in there, and I'll follow up with you after the presentation. If you have a question we don't get to, or whatever, you can reach me here. But we have 10 minutes, I think, so if you have questions, I would love to hear them. I got a question in the back. Yeah, so the first question was, how do you get developers to respond? And I think primarily what you're referencing, hopefully I'm getting it correctly, is when we're presenting a static analysis alert and we're saying, hey, you've created a SQL injection here, go fix it. How do you get developers to actually do that? It comes down to a bunch of stuff. When you get the alert, it's not presented to you in the way that the standard kind of static analysis tools output. When I run static analysis as like a binary tool, I put the binary in and then I get a big list of all the vulnerabilities at the other end of it. And every time I do that, I generate a lot of duplicates, right? I constantly am getting the same list of stuff that I'm ignoring because I'm really focused on a couple of criticals there. So what we did is we just diff that list. So the only alert that a developer is going to get when they're stopped by CodeQL is when they are introducing a net new vulnerability. And so they know it's not only a problem that's happening right there, but it's the thing that they wrote, right? So it's their responsibility to fix it. And they didn't have to sort through a bunch of other people's dirty laundry to understand that. It's only presented to them if their code is introducing the vulnerability. So that's one big piece of it. The second big piece is they're still in context with the flow that they're in, right? They're actively writing that code. They're trying to make this pull request. When you think about how security alerts are generally delivered to developers, the developer makes a pull request, they push it, it goes through without any problem. Somewhere later in the process, somebody runs a security check, and then if it's a critical, it gets escalated to a security manager who then puts it on a spreadsheet, who then sends it to the PM, it gets scheduled on a sprint, who goes back to some developer somewhere adjacent on that team, 12 to 50 days later. And that takes everybody out of the flow, right? They don't know the context that alert's being generated in anymore. When I find out about a problem, let's say it's a SQL injection, and I'm in the middle of writing, this form, I can just add, parameterization right there. It's really simple for me to see, like, oh yeah, I just took raw input from the user. I need to just stop doing that. That's easy. But if I get that later, then I've got to understand, okay, what's this block doing? Where is this present? What am I doing? So giving it just in time is probably the second big thing that we did to get the response rates up. The third thing is the quality of the data that backends the alert. The queries, as I mentioned, are all open source. And so when a rule is triggered, you get to see the text, which is also open source, about how to fix that thing. So it's a community project to curate and understand. When I'm telling a developer you're committing a SQL injection vulnerability, what are the resources I want to give them? I want to give them resources in the language, in the framework that they're using at that time, right? And I want to give them links to the CWEs, and I want to give them links to what happens if you don't do this, and all of that gets delivered with the alert. So that's another really powerful thing that this tool does is there's good curation of the data that's delivered to a developer when they're trying to triage it, so they don't have to go Google around aimlessly. And so that's kind of the trifecta that gets those response rates way up. The second question you asked is whether or not you could do this on private repos, and you can. It is a paid feature, and I'm not trying to sell you anything, so I'll stop there. Yeah, if you're a maintainer of the project, you can see all the alerts that are associated with the project. So if you're working on an open source project, you'll see the pull requests that are having issues. You'll see all of the alerts that we've found in the project historically. You'll see all the secrets and how those were committed. If you're in an enterprise context on private repositories, there is a dashboard that provides you many of those metrics. And in the case of secrets, what I hear a lot from customers that use the feature is that they like it because it will tell them where groups are using unapproved software. Someone will swear up and down, we don't use GCP or whatever the not approved cloud is, right? And there'll be some group that's constantly committing tokens associated with that, so you know that there's some problem over there that you can go stick your finger on. Another really cool workflow that I've seen enterprises adopt, particularly when they have education platforms. So if you use something like Secure Code Warrior or some other kind of like education training system for developers, or you have to send everyone through SOC 2 or something like that, what they'll do is say, okay, if I keep seeing alerts, maybe it's 3 alerts in 90 days or something like that from a particular user on the platform, I'm going to assign them a training in whatever our LMS tool is. And then if that training isn't completed in 30 days or whatever, then I'll write a little workflow to reject their IAM privileges to get to GitHub. So now I can target the training in the language that the developer's using and that they keep contributing this vulnerability in. I can even target it to the specific vulnerability that they're making, right? And then I can require that they take it if they want to continue working. So that's a somewhat aggressive workflow. Like I wouldn't advocate doing that without talking to anybody, but it's possible, and all the APIs are there to do that kind of stuff. So if you're having a challenge where you've got a team that's just not hearing the gospel, you can definitely dial up how assertive you want to be. I haven't added it yet because it's still in beta, but it's stacked updates for Dependabot. So Dependabot's going to look at the build manifest and then evaluate that against the dependency graph. But what gets tricky is when one update causes another update, and that causes another update, and that causes another update, and you're not sure which tree of updates to take, or every change is going to re-trigger the run, right? So now there's a feature called stacked updates that will tell you, hey, this particular set of upgrades of all of these libraries can be done in tandem, and they've passed whatever tests you have as a part of the PR. So they'll be presented with a single pull request to approve, and then can approve that, and I can give you the link for that when we wrap up here if you want. Private vulnerability disclosure. So this is a way of notifying the open source project privately and then starting a branch where we can fix a patch with them that will check for it, in other places, of disclosure data. Sometimes it's finding where the root cause of the problem is, and we just worked on a CVE that was like this, where it was very broad, and so we had to go, okay, it's in this library owned by this other company, right? So that sometimes you just have to traverse who's responsible for the actual vulnerability and then go talk to them before you can notify everybody else, because it gives all of those projects time to update. So if we make an update on a single project, then a PR comes out for Dependabot on all of the subsequent projects that are depending on it. They can all update. So we just kind of, I guess, do that manually. I'd have to talk to maybe how the security team does that, but we can search GitHub, you know what I mean? And if you want to search GitHub in a really sophisticated way that's not a security related, definitely check out cs.github.com. It's codesearch.github.com. Another really cool beta feature that does search of all of GitHub. So if you want to know where is this dependency across all of GitHub, you can get that information out of CS. So we'll use a combination of search tools to figure out who we got to go notify. But this is the feature product that we use to notify people directly. Oftentimes, this data is just in a security.md file, right? And they say, email me if you have a problem. So this is kind of what we're trying to onboard people onto. I think worst case, maybe we could, I don't know. I don't even know. I don't know what we do. Well, I'll talk to you later more. Anything else? I got 2 more minutes. One more question? Any more fun? All right, well, okay, here we go. So it's a great question. No, it's a fabulous question. I didn't make those decisions, and if you were to ask me, I would be very I'd make bad decisions. You know what I mean? We have really awesome product managers, is what it comes down to, and this goes back to GitHub being this platform that everybody's on and giving us lots of data that we can analyze. It's easy for us to do an A/B test and understand something. We have access to maintainers and open source communities to ask them how they'll interact with different parts of the platform. So it's part of just the advantage of being GitHub is you just have this miraculous view into how developers do their work day to day, and so we can understand those types of things. But the product managers work tirelessly at this. There's a whole group of people that have to think about any button or widget that goes onto GitHub.com. And if you see a new feature on GitHub, be sure that hundreds of people plus one that thing before it went out the door, because it's not a low bar to ship a feature on GitHub, and they work really, really hard at over focusing on developers' problems in order to solve them. So I think we have a great PM team, and I'm super privileged to be able to work with them. GitHub's a really exciting place to be, because any problem that is associated with source code is kind of in our realm of stuff we can solve. And so the hardest problem of being an employee there is figuring out what to focus on. There's a million decisions that we could make that could probably positively impact someone, but figuring out what the highest priority one becomes really, really difficult for us because our scope is just really big. But there's lots more good stuff to come. This is just the security features we've launched in the last 3-4 years, but there's a gajillion other features. We've launched 6 new product lines, so if you want cloud-hosted IDEs, those are available on GitHub. If you want security tools, you can get those on GitHub. If you want AI code completion assistance, you can get those on GitHub. So there's tons of new stuff that's gone in. It's very hard to keep track of all of it, but follow the changelog and you'll see more of those decisions. And know there's a whole miniature army of people working in the background to make sure that those are really high quality changes to the platform. Thank you so much for being an awesome audience. If you asked a question today and you'd like a t-shirt, I have some coupons for you that I can give you if you come up to the front, and they'll let you buy a t-shirt on the GitHub shop. So come grab one of those, and thanks for being a fantastic audience. Thanks so much for having me here, and I hope you guys have a great day.